Okay, in number 13, we're going to solve this rational expression or rational equation. So we want to eliminate the denominators so we don't have to deal with fractions. So to do that, we're going to factor the first expression, x minus 1 and x plus 1. It's a difference of two squares. This denominator is going to stay x plus 1, and this is going to stay x. So we need a common denominator. So we're going to multiply through by x minus 1, x plus 1, and x, because that is what we need to multiply by to get rid of all the denominators. Okay, so when we multiply this first expression by this whole denominator, LCD, the x minus 1 and the x plus 1 will cancel out, and we would just be left with 5 minus x times x from there, plus, now here the x plus 1s will cancel, so we'll have 7x, excuse me, 7x times x minus 1, and that will equal, here in the end here, the x's cancel, so we'll keep our 6 times x minus 1 times x plus 1. Okay, we can now multiply through and solve. So we have a 5x minus x squared plus 7x squared minus 7x, and then we can this x minus 1 times x plus 1 is just x squared minus 1 from up here before, so we can make this x squared minus 1 multiply through by 6. You get 6x squared minus 6. Let's combine our like terms on the left side. Negative x squared and a 7x squared is 6x squared, and negative 7x and positive 5x is a negative 2x, and that's going to equal negative or 6x squared minus 6. 6x squareds are going to cancel, so we're left with negative 2x equals negative 6, so x is going to equal 3. Now we have to set the domain. We have to have the restrictions so that nothing that we substitute in for our answer will give us 0 in the denominator. So let's set our domain. X can be any number such that x cannot equal, right here, 0. What makes this denominator 0 is negative 1, so we can't equal negative 1. And then this is the factored form right here, so we have 1 and negative 1 are the zeros for this denominator, and so we can just add a positive 1 as well. So our domain is any number except for 0, negative 1, and 1. Since 3 is not one of those three numbers, 3 is our solution. Okay, let's go on to number 14. Two pumps of different sizes working together can empty a fuel tank in 8 hours. The smaller pump takes 6 hours longer than the larger pump to empty this tank. If the larger one is out of order, how long does it take the smaller one to do the job alone? So this is a working together problem. So we're going to set up a little chart. We have two pumps. So we have a small pump, we have a large pump, and we have how long it takes them to do it together. Okay. Then we have two columns we can add here. How long it takes in terms of, let's see, what are we doing? Hours. So how many hours it takes. So time in hours. And then the rate per hour here. Okay, so it says that two pumps working together, it takes 8 hours. So we'll put an 8 here. The smaller pump takes 6 hours longer than the large pump. So we don't know the large pump, so we'll put a variable there for large pump. But we know the smaller pump takes 6 hours longer. So we can do the large, x, plus 6 more hours for the small. Now the rate per hour, if this is the total time, it can do 1 over x plus 6 of the job in an hour. And this will be 1 over x And same concept, 1 over 8 here. Now to set up an equation, the two parts have to equal the whole. So 1 over x plus 6 plus 1 over x is going to equal 1 over 8. So we can just solve this like the problems above, finding a common denominator and multiplying through. So for the denominator, we're going to need 8, we're going to need x, and we're going to need x plus 6. Okay, so we'll multiply through, and 1 over x plus 6 times that LCD will cancel out the x plus 6, so we'll be left with an 8x. The x will cancel here, and we'll be left with an 8 times x plus 6. And the 8th here will cancel, and we'll be left with an x times an x plus 6. So we can simplify or expand this out. Distributive property in both these cases. And then we can simplify on the left side. We get 16x plus 48 equals x squared plus 6x. And then we can get everything to the right side since we have a quadratic here. So we'll have 0 left on the left side. X squared, we'll subtract the 16x over, and we'll get a negative 10x, and subtract the 48 over as well. Okay, so that's not going to be factorable, so we're going to have to use another method. We could either complete the square or use the quadratic formula. I'm going to complete the square. So x squared minus 10x is equal to 48. And then I can complete the square. X squared minus 10x plus, to get the perfect square, we have to take half of 10, which is 5, and square it, which is 25. And then what we do to one side, we have to add to the other side. So we'll add the 25 to both sides. Let's factor this down. X minus 5 squared is equal to 48 plus 5. Let's see, that's going to be 73. So then we can take the square root and then add the 5. And so x is going to be 5 plus or minus the square root of 73. Okay, so then we want to get what that value is. So you can take your calculator and multiply that out. Just do 5 plus the square root of 73 and 5 minus the square root of 73. So 5 plus the square root of 73 is 13.5. And the other answer is going to be 5 minus square root of 73, which is negative 3.5. Now, since the x represents an amount of hours, we're not going to use this one, and our answer is going to be 13.5. So we have to make sure we answer the question. It says, if the larger one is out of order, how long will it take the smaller one to do the job? So we actually have to substitute the x in for the small one alone is x plus 6. So the small one's going to take 13.5 plus 6. So that's going to be 19.5 hours to do the job alone.